Hello, my name is Evan Duffield, and this is a video series about Dash. And in this video, we're talking about Masternode services, such as our decentralized Oracle implementation, instant transactions, and our DarkSend implementation. So how do you add value to the network through a two-tier architecture? On the first tier, we have just the regular clients that are on the network. That can be any full node that's connected, any full node that's sending transactions around the network or anything else like that. And then we have a second tier network, which is the Masternode Network. And by utilizing the second tier, we can actually form decentralized oracles. These are also known as Sub-Quorums, which allows us to do things like instant transactions and decentralized Masternode payments on the network. Besides that, you can also connect to the second tier to do DarkSend mixing for privacy. And by utilizing the second tier all at the same time, we can actually do full quorums, which basically lets everyone that owns a Masternode vote on something to either fund a given project or make a decision on behalf of the network. The Sub-Quorum system, or the Decentralized Oracle implementation, utilizes statistics and probabilities to secure the network. And this is done using the 1000 dash requirement. So there can only be a certain amount of masternodes on the network at a given time because of this requirement. And that means that to control a majority of the network, you have to control millions of dollars of infrastructure. And if you were in control of that much infrastructure, you probably wouldn't want to attack the network. And even if you wanted to attack the network, the statistics say that it's nearly impossible even if you control a majority of the network. The decentralized Oracle implementation essentially just is the network asking specific masternodes a question. And to do this, you propagate a message around the network. And then as the message propagates, it finds the masternodes that the question was intended for, using a deterministic secure algorithm. And then those masternodes answer the message by signing another message and then propagating that. Once the network has significant messages from the targeted masternodes, it can then answer the question in such a way that is completely secure. For example, let's say we have an Apple stock and we want to know what the answer is for how much is Apple currently trading. And so someone on the network asks the network, how much is Apple trading for right now? And then that network message propagates, and the 10 masternodes that are intended to find out the price of Apple all reach out to external APIs, pull down the price, and then they compare the price that they got to the price that other people got. If the price is close enough, then the network would select a median price and then go with that. And so now we have a secure price for Apple. And you can also do this for things like instant transactions, where you ask, is this transaction valid and can I lock it? And if you can lock the transaction, then now we have a double spend proof implementation of instant transactions. At a lower level, the Sub-Quorum system works by taking the mining proof of work from a block. And the mining proof of work hash is a very, very large number that cannot be forged. And it takes the entire network a period of time to generate that. And they're generated continuously. And so using that secure number, we then select 10 masternodes based off of their numbers. And masternodes have a number which is the 1000 dash input that created them originally. And so by taking the distance between the two numbers, we can order them into a ranking. And then we can take the top 10 closest numbers to the proof of work hash. The process of instant transactions is relatively simple. The network will select masternodes based off of the input of the transaction in question. And then the transaction propagates around the network, finds its target masternodes. Those masternodes look at their own memory pool to see if the inputs are valid. If the inputs are valid, then they sign a message send it out back to the network again. Signatures are collected, a threshold is met, and then rules are enforced on the entire network after that. After the enforcement is engaged, no peer on the network will accept a conflicting transaction or any type of conflicting message for whatever the given quorum was. In this case, they would even reject blocks that were mined with the conflicting transaction. The DarkSend implementation, on the other hand, doesn't use quorum technology at all. Masternodes just simply host mixing sessions for users. And all this means is a user will reach out to a masternode, they will wait in queue. Once enough users have entered the queue, mixing starts, and then the users send money to themselves through that masternode. And this is why it remains trustless, because the user's money actually never leaves their own wallet. The reason it's secure is because we use denominations in all of the transactions. So you would only pay yourself in tens, or you would only pay yourself in 50s, or you'd only pay yourself in 100s. And all other users in that mixing session are required to do the same thing. And this is called anonymity through ambiguity, meaning that you can't tell anything apart in the transaction because there's no other information other than the denominations. Fees for utilizing the DarkSend service are actually charged separately from the mixing transactions to increase the anonymity that's on the network. This is something that would be incredibly difficult to do, and we have special rules in the client to allow it. When using DarkSend, after you have successfully anonymized coins, you'll end up with a private and a public balance within your wallet. And all this means is that you can spend your private balance at any time into the future. And this is so that you can't execute timing attacks on our system. A timing attack is where you would look at all of the mixing sessions and then you would try to correlate them with users spending their money later on. And if they happen too close because one is required right before the other one happens, then you can break users' anonymity. Here you see a Bitcoin example transaction. On the left is where the money came from, and on the right is where it went to. One of those is the target person or company that it was spent to, and the other one is the change address where the user is receiving back change to their own wallet. And so this is very easy to understand, and if any of these addresses are de-anonymized in the future, then it means that everything after that in the blockchain is not anonymous as well. So here you can see an example transaction for Dash, and everything is denominated up until the point where it's actually spent. And this is where the security comes from. So how do you use DarkSend? Well, it's as simple as clicking that button, Start DarkSend Mixing. And then when you actually want to spend your DarkSend private balance, you can use these checkboxes in the Send tab of the client. And depending on which one you want, you click the checkbox, fill out the form as you normally would, and then click Send. So that's it for the Masternode Services video. In our next video, we're going to be exploring our decentralized governance and budgeting system, how it works, and how it benefits Dash. Thanks for watching.